Okay, so these guys are going to have pretty straightforward equations to solve. The next set of problems, 5 through I think it's 9, are going to apply a property, and then their equations algebraically are going to be a little bit more difficult to solve. So let's take a look at a couple of these. I think this first one's not too bad. The property that we're going to apply is when you have a factor out front of a logarithm, you can move it up into the exponent. All right, so I'm going to take that 1/2, I'm going to move it up as an exponent. I'm going to take the 2, move it up as an exponent. So now I've got log base 3 of x. I could put the square root of x down, or I could put it as a 1/2 power. And then I've got log base 3 of, well, 2 squared, right? I was thinking about putting 4 right here, but I just thought I'd put 2 squared because I did say just move the exponent up there. Now I can say x to the, well, square, how about I do the square root now? Square root of x is equal to 4, because look, if we have log base 3 of something is equal to log base 3 of something over here, the two expressions, let's put parentheses around this, the two expressions inside the parentheses need to be equal to each other, right? All right, so, I mean, well, I'm not going to say more about that, but they've got to be equal to each other, right? Anyways, to get rid of a square root sign, we could just square both sides of the equation, right? So I end up with x is equal to 16. I just squared both sides. Square both sides. Okay, so this wasn't too much more difficult than the first bunch of problems, but we do have to apply a property before we interpret the logarithms. And actually, somebody might say, well, you're not really interpreting the logarithm here. You're not saying like 3 to this power is equal to that. I'm just saying these two expressions have to be equal to each other, all right? Okay, now here's where it gets a little bit trickier. We have a property that we need to apply, and, well, 2 of them, actually. We're going to bring the 3 up as an exponent, so this 3 is going to go up as an exponent, and then we're going to combine the 2 logarithms. Because it's addition, we can multiply and make 4 times x minus 1 squared. Okay, so let me try all that. Log base 2 of x minus 1 squared times 4, because that 4 can be multiplied over here because that plus sign right there. Okay, that's all equal to 5. So I applied 2 properties. One, I'm bringing this up as an exponent, and then a sum can be written as 1 logarithm with the arguments, I think they call them, the 4 and the x minus 1 multiplied together. All right, now I'm going to interpret the logarithm. What does this mean? I'm raising 2 to some power to get all this stuff. Oh, hey, they're telling us what power we're going to raise 2 to. 2 to the 5th power is equal to, I'm going to put the 4 in front. Usually I have a 4 in front of a binomial squared, something like that. All right, so, well, look, I could do some simplifying here. And again, you know, applying 2 properties could be kind of intimidating. And then you get down here and you're like, well, shoot, man, what do I do here? Well, this right here, 2 to the 5th is 32. And then I'm going to divide that by 4, right? So I'm going to have 32 divided by 4 is equal to x minus 1 squared, right? Well, 4 goes into 32 8 times, so now I've got 8 is equal to x minus 1 squared. And then I've got to simplify, you know, my squared here. I'm going to take the square root of both sides. And look, the number in here could come out to be a positive 8, or the number in here could come out to be a negative 8. Excuse me, square root. What am I talking about? This number right here has got to come out to be a positive square root of 8, and then when I square it, it becomes 8. Or it becomes a negative square root of 8, and then I get squared, and that would give me positive 8. Anyways, let me just try this. I get plus or minus the square root of 8 is equal to x minus 1. Do you see how, like, this one's a little bit trickier to solve, because if you forget this plus or minus over here, you're not going to make it. Right? And somebody might say, well, I'm going to square this, move the 8 to the other side, and apply the quadratic formula. Well, I think that is going to be a little bit more difficult than you need right now, but there are equations where you're going to need the quadratic formula. And then I'm going to add 1 to both sides, so I get x is equal to 1 plus or minus the square root of 8. We're getting closer to what they probably want us to report the answer as. They might say, give an exact answer simplified. And remember, the square root of 8 is the same thing as the square root of 4 times the square root of 2, because 2 times 4 is 8. And the reason I'm writing it like this is because I can take the square root of the 8, so I get plus or minus 2 square root of 2, and I still have that 1 over here. So you can see how, man, this can kind of ratchet up in level of difficulty pretty quickly. Thanks for watching. Try 5 through 9 right now.